Welcome to the spooky section. Half angle formulas. Okay, so here we're going to do the half angle formulas, and they're really not that bad. So to start, let's look with the angle reduction formula. Notice that the angle reduction formula, we had a bunch of them. One of the angle reduction formulas look like this. Well, what if we said alpha over 2 is theta? Just out of nowhere. What if we said that? Then what happens? Theta is alpha over 2. We get sine squared of half of an angle equals 1 minus cosine. What's double that angle? What's double half of alpha? Well, it's just alpha. So if we want a half angle formula, all we have to do is square root both sides. So if we square root both sides, we're going to get the sine of alpha over 2 equals plus or minus square root of 1 minus cosine of alpha over 2. And be very careful. There's something important here. First off, remember when you do take the square root of both sides, you do need a plus or minus. But second off, this doesn't mean both. This means either. We have to choose the right one. And specifically, we're choosing the one, depends on what quadrant alpha over 2 is. All right, so if the sine of alpha over 2 is positive, we choose the positive. So if alpha over 2 is in the first or second quadrant, we choose the positive. If the angle alpha over 2 is in the third or the fourth quadrant, then we'll choose a negative because sine is negative right there. Okay, so that's what the plus or minus means. That's what the half angle formulas look like. And again, if you're using this identity sheet, they're written a little bit differently. You just take the square root and u is alpha over 2. Okay, but if you'd like to write them all down, you can do that as well. So if you write them all down, again, we're going to get that the sine of alpha over 2 is plus or minus the square root of 1 minus cosine of alpha over 2. The cosine of alpha over 2 is very similar. Again, plus or minus square root of 1 plus cosine of alpha over 2. And the tangent of alpha over 2 is plus or minus the square root of 1, minus is on the top, I believe. Yep, 1 minus cosine of alpha over 1 plus cosine of alpha. And there's a couple of different forms for tangent, but this is the one I always see, so I'm not even going to include the other ones. So these are the half angle formulas. If you want to write these down on your own identity sheet, you can. Again, this identity sheet is kind of like me. It likes to write as few things down as possible. And since they're really the same formula, it doesn't write them down. It's the same thing like with the plus or minuses down here. So we don't have to write 6 of these. We just write 3. But it can be helpful if this notation is confusing for you to just write them out like right next to each other or something like that. We're not going to use these last two chunks, so you could write it in that space if you wanted. All right, let's use these. Example 8. Example 7. Evaluate the sine of negative 15 degrees exactly. So one of the ways that we could do this with would be angle sum or angle difference. We did this before in 9.2. But let's use a half angle formula. Because even though negative 15 degrees is not an angle that we know much about, it is half of negative 30 degrees. Right? So this is just going to be the sine of 1/2 times negative 30 degrees. So our alpha, if you will, is negative 30 degrees. This is, again, the same strategy as we did in 9.2. We're rewriting these two things in terms of something that we know things about. In this case, negative 30 degrees. In 9.2, what we did is we'd say this is negative 45 degrees plus 30 degrees, and that's how we'd start that one. But here, we're going to say that this is 1/2 of negative 30 degrees, and then use the formula. The sine of alpha over 2, which is 1/2 times alpha, is the plus or minus square root of 1 minus cosine of alpha. Alpha is negative 30 degrees all over 2. Right? That's the sine of alpha over 2, this formula. Now, do we need the plus or do we need the minus? It depends. Look at alpha over 2. What quadrant is alpha over 2 in? And again, alpha over 2 is negative 15 degrees. What quadrant is this in? Quadrant 4. Is sine positive or negative there? Sine's negative. So we use just the negative part. All right, so when I say you have to choose the right one, it's just because this is what we're looking at, the sine of negative 15 degrees. Is this answer going to be negative or positive? It needs to be negative because that's in the 4th quadrant, and sine needs to be negative in the 4th quadrant. So we're going to have the negative square root of 1 minus, what is the cosine of negative 30 degrees? That's right here. Reference angle is 30 degrees. We get this special triangle. You can add a negative here if you want. The cosine is positive root 3 over 2. Cosine's positive in the 4th quadrant. You ready for some algebra? Because we got to simplify this. So inside the square root, we have a complex fraction. The book also makes you, wants you to rationalize denominators, but I don't care about that too much. But complex fraction is bad. So to get rid of the complex fraction, and again, this is all inside the square root, we multiply by the LCD. I'm going to do this in a different color. The least common denominator is 2. That negative is still out in front. We still have a big square root. When we distribute that 2, we get 2 minus root 3 over 4. And now we can simplify a little bit more because we know the square root of 4. We get negative square root 2 minus the square root of 3 all over 2. And a square root inside of a square root is not good, but that's not really something that I want to spend time talking about. So I will accept this as your final answer. All right. There are a couple of ways of getting rid of this. Some of them will always work, I think, but not going to worry about it. As long as you don't have a complex fraction, square roots inside square roots are okay. And I think actually in this one, you might not be able to get rid of it in the first place. And I don't care if your denominator is rationalized either. Just make sure to get rid of complex fractions for these. And again, as with all of these, you really can check your answer. Sine of 15 degrees. Why is this wrong? By the way, this is wrong. Sine of 15 degrees is not 0.65. Remember, if you're using Desmos or on your own handheld calculator, whatever, make sure, and on Desmos you can do this with the wrench icon, make sure that you're in the right thing, degrees or radians. This is a sine of 15 degrees. It's 0.258. Okay? Is that the same as negative? Oops, we wanted sine of negative 15 degrees. Is this the same as the negative square root of 2 minus the square root of 3 all over 2? Those numbers look pretty equal to me, in my mathematical opinion. Great. Don't ever forget that you can check your answers. If you're ever curious and say, Jason, how would I check my answer for this problem? Ask me about it. I love checking answers. Any opportunity for me to help you check your answers is great, and I will take it. I've said this once and I'll say it again, but I have a lot of reasons why I want all of you to do well. Many of them are selfish, but some of them are not selfish. But it's a heck of a lot easier to grade a perfect quiz, I'll tell you that much. All right, example 8. Given a tangent of some angle is 8/15, and alpha is in quadrant 3, find the following exactly. And the exactly part is really important here, because we could find an approximation for alpha using inverse tangent. Inverse tangent would give us some information about what alpha is, and then we have to use that information to find what alpha actually is, because remember, inverse tangent is going to give us something in the first or the fourth quadrant, but we know alpha is in the third quadrant, so we'd have to move it around a little bit. But again, that's going to be an approximated answer. We're going to use what we know about half-angle formulas to find this information. So we use a half-angle formula. Sine of alpha over 2 is plus or minus square root of 1 minus cosine of double that, just alpha, all over 2. And this is where things get a little tricky. Be very careful. Do we need the plus here or the minus? Alpha is in quadrant 3. What is alpha over 2 in? Well, if it's in quadrant 3, we don't know how big alpha is, but let's just pretend that alpha is in 0 to 2 pi. We don't know that, but if it is in 0 to 2 pi, I'm not even going to write that assumption down. If it is in 0 to 2 pi, I really should write it down. Let's look at the coterminal angle. The coterminal angle, because we don't actually know how big alpha is. We know it's in the third quadrant, but we don't know how big it is. Coterminal angle in the third quadrant, that's between, right? If we're in the third quadrant, then we're bigger than 180 degrees. And we're smaller than 270 degrees. Right? We're somewhere over here. Well, how does alpha over 2 behave? Or we can look at its coterminal angle theta. You can just call this alpha. I don't care. Well, if we divide everything by 2, we get that 90 degrees is between this angle divided by 2, which is between 135 degrees. What quadrant is theta over 2 in? It's bigger than 90 and smaller than 135. It's somewhere over here, somewhere in this region. Second quadrant. Okay. So we know this is in quadrant 2. And is sine positive in quadrant 2 or negative? Sine's positive. So we toss out that negative and say, okay, we only use the positive part here. What's cosine of alpha? We don't know. We know the tangent of alpha. We don't know the cosine of alpha, though. We're going to have to not draw a triangle. We go do more work on the side. All right. So alpha's in the third quadrant, and the tangent is 8/15. I think there's an 8, 15, 17 special triangle. But let's check. 8 squared plus 15 squared. Is that equal to 17 squared? Yeah, it is. Great. You can use Pythagorean theorem to get this as well. And again, if you want to use negatives here, you can. You don't have to. The cosine of that angle alpha is going to be negative 15/17. I'm going to write positive. Cancel those negatives. And just like before, we need to simplify this complex fraction. So what I'm going to do is multiply by the LCD on the top and the bottom. It's going to be the square root of 17 plus 15 over 34. And again, the book will want you to rationalize the denominator, but I don't require that. And we're going to get 32 over 34. We can simplify this though in a couple different ways. You could reduce it. Going to do the square root of 16 over 17. And the square root of 16 is just 4. All right, so this is A-OK. I don't need you to rationalize the denominator. But the book would rationalize the denominator. And the book would give you an answer of 4 root 17 over 17. So be aware of that when you're checking your answers. And again, I said we can check our answer for this one as well. What is 4 over the square root of 17? Is that the same as the sine of alpha over 2? What is alpha? Well, we don't know alpha exactly, but it's related to the inverse tangent of 8/15. So we might be off by a sign error because I don't actually want to calculate alpha. No, let's calculate alpha exactly. If you wanted to calculate it, not exactly, but get an approximation, you do arctan of 8 over 15. That's going to give you the alpha, the reference angle, but it's in the third quadrant. We have to add 180 degrees. What is the sine of 1/2 times alpha? Are these the same? Yeah. So you could solve for alpha and get an approximation this way, but the exact answer is 4 over the square root of 17. And that 4 over the square root of 17 is what I need from all of you. But that's one way of checking your answer, using approximations. You could go through this really quickly as well. You could do the same thing for cosine, which I would recommend. Pause the video, find what the cosine of alpha over 2 is, and see if we get the same answer. Again, plus or minus 1 plus cosine of alpha over 2. By the same logic, we're in the second quadrant. Cosine needs to be negative. We have negative square root of 1 plus cosine of alpha. Cosine of alpha, just like before, is negative 15 over 17. That turns this into a minus. Just like before, we multiply the top and the bottom inside the square root by 17 over 17. Get 17 minus 15 over 34 is the square root of 2 over 34, which again will simplify to 1. The square root of 1 is 1, divided by the square root of 17, or the book's answer would be negative root 17 over 17, if you rationalize the denominator. I went through that quick, just to give you a write-up, but hopefully you did it while paused. And then finally, tangent is just sine over cosine. So the tangent of alpha over 2 should just be those two answers that we have. But if we wanted some practice, we do 1 minus cosine of alpha over 1 plus cosine of alpha. Tangent in the second quadrant is negative. We'll have the square root of 1 plus 15 over 17 over 1 minus 15 over 17. Inside the square root, simplify by multiplying by the LCD. Distribute 17 plus 15 over 17 minus 15. And you'll get 32 over 2. Square root of 16. Square root of 16 is 4. Is that sine over cosine? Sine is 4 over root 17. Cosine is negative 1 over root 17. The root 17s would cancel, and you do get negative 4 for sine over cosine as well. All right, let me know if you have any questions. I didn't spend a lot of time on these last problems, so I'm okay if you have some clarification questions, if you're curious where certain things came from. But otherwise, we'll do some more problems in the selected homeworks problem video after this. Good luck.